Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be just showing you how to calculate the equilibrium constant. And before guys I start, please do share this video to your peers. I believe that a thing or two that we'll mention here might help them a lot. So please guys, do help us grow the channel as well by just subscribing. Okay, we are told that 5 moles of nitrogen gas reacts with 5 moles of hydrogen gas to form ammonia gas. This happens inside a 2 cubic decimeter closed container. And then we are told that the reaction reaches equilibrium at 450 degrees. Upon analysis of the equilibrium mixture, it is found that the mass of ammonia is 20.4 grams. They just want us to calculate the equilibrium constant at 450 degrees. Now, for us to be able to calculate the equilibrium constant, we must know the concentration of reactants as well as products at equilibrium. There is a table that we use guys to help us calculate the Kc value. We do have a table now. I simply have nitrogen, I have hydrogen, and I also have ammonia, NH3. Okay, we'll simply need the initial number of moles, the change in number of moles, the number of moles at equilibrium, as well as the equilibrium concentration. So the I over here represents the initial number of moles. The C just represents the change in moles. Are you together? The C represents both the used moles of our reactants as well as the produced moles of our products. Né? And then this E over here represents the number of moles which are present at equilibrium. And then the concentration there is just the concentration of our products and reactants at equilibrium. Are you together? Remember that guys, Kc, the equilibrium constant is just the ratio of the concentration of products to the concentration of reactants raised to their stoichiometric coefficient. Our products, we simply have ammonia, that's NH3, and the coefficient of ammonia is simply equal to 2, right? So that means the exponent will be 2. Then for our products, we do have our nitrogen and our hydrogen. Our hydrogen has a coefficient of 3, that's why the exponent will simply become 3. So if I can simply find the concentration of my reactants and products at equilibrium, that means I can simply find the equilibrium constant. Okay, initially how many moles were we given? 5. Okay, there are 5 moles of nitrogen as well as 5 moles of hydrogen. But initially guys, ammonia was not formed. Ammonia was formed as the reaction progressed. Ammonia was formed whenever we used nitrogen and hydrogen. Né? But initially we had 0 moles over there. And then what else are we told? We are told that at equilibrium 20.4 grams of ammonia were formed. We can simply find the number of moles of ammonia at equilibrium. How can you do that? Number of moles of ammonia at equilibrium, NH3, is just equal to mass divided by the relative atomic mass. The mass is just equal to 20.4. The relative atomic mass, for nitrogen, I simply have 14. Hydrogen is 1. But since I have 3 of them, that's 1 multiplied by 3. So whenever I punch my precious calculator, I'll simply say 20.4 divided by 14 plus 1 times 3. So I'll simply find an answer of 1.2 moles. That means guys, at equilibrium, I will find 1.2 moles of my ammonia. Are you together? But remember that guys, I have used my products to form, or rather I've used my reactants to form products. That means there's an amount I subtracted from the nitrogen as well as the amount subtracted from the hydrogen just to form the ammonia. So we must add on the products. Okay, initially guys, I had 0 moles. Initially I had 0 moles of ammonia, but at equilibrium I find that I now have 1.2 moles of ammonia. That means the reaction has produced 1.2 moles of ammonia. Now let's find the number of moles that were used for hydrogen, the number of moles that were used for nitrogen as well. Yeah? Okay, I know that I only need 1 mole of nitrogen to form 2 moles of ammonia. But now I did not form 2 moles, but I only formed 1.2 moles of ammonia. I want to know how many moles of nitrogen did I use to form that amount. All I have to do, guys, is to just cross multiply. Né? And whenever I cross multiply, I'm only focusing on stoichiometric coefficients. 2 multiplied by x, that's just 2x. 1 multiplied by 1, 2, that's 1.2. Then x will simply be equal to 0.6. X will simply be equal to 0.6, right? But remember that, guys, x represents the number of moles that were formed, that were used, the number of moles of nitrogen that were used to form ammonia. It was just 0.6. 0.6. Né? Let's do the same thing for hydrogen. I need 3 moles of hydrogen to form 2 moles of ammonia. But now I did not form 2 moles, I only formed 1.2 moles of ammonia. I want to know how many moles of hydrogen did I form. Just cross multiply, you'll have 2x being equal to 1.2 times 3. That will be 3.6, but let me confirm. Yeah, it is 3.6. It is 3.6, right? Then whenever I divide by 2, 3.6 divided by 2 will simply be 1.8. So I only used 1.8 moles of my hydrogen to form that amount of ammonia. Are we together? Okay, and then now, guys, let's go and check how much do we have at equilibrium. How much do we have at equilibrium? At equilibrium, for my nitrogen, initially I had 5 moles, but I've only used 0.6. That means I'll be left with 4.4 moles. Are you together? For my hydrogen, I had 5 moles, but I only used 1.8 of my 5 moles. That means I'll be left with 3.2 moles. After finding the number of moles that I have at equilibrium, I can simply go and find my equilibrium concentration. Remember, the volume was given to us as 2 cubic decimeters. Ne? Let me write it over here. The volume was given to us as 2 cubic decimeters. So for me to find the concentration at equilibrium, I just need to divide the number of moles by 2. So over here, I'll say 4.4 divided by 2. This will just give me 2.2 moles per cubic decimeter. And then 3.2 divided by 2. This will just give me 1.6 moles per cubic decimeter. And then 1.2 divided by 2. This will just give me 0.6 moles per cubic decimeter. But I'm not yet done, guys. Yes, I do know the concentration of both my reactants and products at equilibrium. I can therefore go and calculate my equilibrium constant. Since I have gases only, guys, that means I must include all my products and all my reactants. Remember that, guys, whenever you're finding equilibrium constant, you must only include gases and aqueous solutions. Please. If you have solids and liquids, you must exclude them on your calculation. Okay. The concentration of ammonia is just 0.6. That's squared. And then for nitrogen, I simply have 2.2 squared. And then I have 1.6 all squared. And therefore, let's check the final answer. 0.6 squared. Why did I square the 2.2 now? Divided by 2.2 multiplied by 1.6 cubed multiplied by 1.6 cubed. So the final answer would have been 0.03, actually just 0.04 whenever you round it off to 2 decimal places. This would have been your Kc value. Now guys, okay, let's go and recap on how we calculated our equilibrium constant. Yeah? Remember that guys, initially we were told that we reacted 5 moles of nitrogen and 5 moles of hydrogen to create ammonia. That means at the beginning stages, ammonia was not there. That's why the initial number of moles for ammonia, we had was 0 over there. But at equilibrium, we were told that we ended up having 20.4 grams of ammonia. We changed that mass into number of moles, and then we got 1.2 moles of ammonia together. But remember that guys, initially I had 0, but now at equilibrium I'll have 1.2. That means my reaction has produced 1.2 moles because I had nothing initially, but whenever things are balanced, I ended up with 1.2. That means I have gained 1.2 together. And then I used that 1.2 to find the number of moles that were used to produce ammonia. But remember that for me to produce ammonia, I must use both my nitrogen as well as my hydrogen. By applying ratio and proportion, I found the number of moles of nitrogen that were used to be 0.6 moles and the number of moles of hydrogen that were used to be 1.8 moles together. And then I went to find the number of moles that I have at equilibrium. Initially for nitrogen, I had 5 moles, but I've only used 0.6. That means I'll be left with 4.4 because I'll just subtract the 2. Same thing applies with hydrogen. Initially I had 5, but I've only used 1.8. That means I'll be left with 3.2 at equilibrium. And then for me to find my equilibrium concentration, just take the number of moles at equilibrium divided by the volume of the container. Then you'll go and find your equilibrium concentration. After finding your equilibrium concentration, then you can go and calculate your equilibrium constant. Together. Therefore, our equilibrium constant is basically equal to 0.04. That's how, guys, you're supposed to tackle this question over there. I really hope the video helped you out. So please do stay tuned and wait for more videos. Thank you.